Hello and welcome back to the Mind Math by McGraw-Hill homework tutorial. I'm Mr. Galvez, and in this video we'll be taking a look at Chapter 12 Geometry section, Lesson 10. Lesson 10, Build Composite Figures. Now, I find this to be a fun chapter, or a fun lesson, because we'll be looking at three-dimensional figures, the way we're looking at in lesson 9. But because they're composite figures, we'll be looking at a combination of two or more different 3D figures. So a composite figure is a figure that's made up of two or more three-dimensional figures. And here's a rough drawing of two different three-dimensional figures. They're both rectangular prisms. There's a yellow one on top that's smaller in size, that has less cubes. And there's a larger prism down here at the bottom that's kind of pinkish in color. And when we're looking at these figures, we're going to notice that not every section counts as a cube. Okay, so for example, this corner here has 3 sections, but these 3 count as one cube. Same thing with this little yellow tower up here. This tower is made up of of 3 sections: the bottom layer, the middle layer, and the top layer. So you can think of this having as having 3 cubes: a cube on top, a cube in the middle, and a cube on the bottom. The lower section has lots of cubes. Okay, now in this diagram, it's basically a sketch of this diagram over here, except I separated the top layer. So here's how we measure volume. If you recall, volume is the space that's inside the space that's inside a figure. So here we have basically 2 different volumes. If you combine these 2 volumes together, you'll calculate the composite volume. And if you remember, we're going to look for length times width times height. So here's the length of the pink one. Length 1, 2, 3. Width is going to go back 1, 2, 3. Height is going to be going up 1, 2. Start right there. 1, 2. So 3 times 3 times 2, which is what I have right here for section B. Volume is 3 times 2. And as you know, 3 times 3 is 9, and 9 times 2 is 18. The top figure is composed of 3 cubes, and the way we measure this is you can calculate it by multiplying the length times the width going back times the height going up. Okay, and here the length is 1, the width is 1, and the height is 1, 2, 3. 1, 1, and 3. The volume on figure A over here is 1 by 1 by 3. So we're basically looking at 3 cubes, 3 cubic centimeters. So 3 cubes are what make up figure A. Now when you add up the 3 cubes on figure A plus the 18 cubes on figure B, we get a composite total of 21 centimeters cubed, 21 cubic centimeters. Okay, and that's what we can consider the composite volume. Another way of looking at this is by using the models that I had created in a previous lesson. Here is a 3-dimensional figure that you can think of as being composed of 4 cubes, 2 in front and 2 in back. Okay, now we don't want to say here's a 1, 2, 3, 4, 5, 6, 7, 8, 9 cubes. I want you to look at it as, you can look at it a few different ways. You can look at it as 2 cubes on the bottom and 2 cubes on top. If we look at it this way, you can look at it as just one layer of 4 cubes. Here's 1 cube. Okay, to make it composite, I can add this here. And now we're looking at 4 cubes on the bottom plus 1 cube on top. This is a composite figure of 5 cubic units. If you want to look at it this way, we're still looking at 5 cubic units. If I add this, if I move this over here, again, it's 5 cubic units. If I grab this model over here, you can think of this as having 4 cubes on top and 4 cubes on the bottom. Okay, for a total of 8. So the volume here is 2 times 2 times 2, 8. Here we're looking at 8 cubes, 8 cubic units. If I put this little guy up here on top, I'm going to add 1 more unit, and the composite volume will be 9 cubic units. Okay, let me switch this up. If I switch it to make it look like this, well, now I have a different volume. Okay, I'm gonna have the pink one has 4 cubes. The green one, well, that one has 8 cubes. 8 cubes. So in total, we're looking at a length of 2, a width of 2. 2 times 2 is 4, and a height of 1, 2, 3, a height of 3. 2 times 2 times 3. 2 times 2 is 4. 4 times 3 is 12. Here we're looking at 12 cubic units. A composite of 12 cubic units. And let me give you one more example. Okay, we'll use this model over here. And this one from yesterday's lesson has a volume of 3 by 2 by 2. 3, the length is 3. 1, 2, 3. The width was 2. 1, 2. And the height was 2. 3 times 2 is 6. Times 2 is 12. So this has 12 cubic units. If I add these 4 to the 12, this is the composite volume of 4, 8, 12, 16. Here we have a composite volume of 16 cubic units. Okay, now if I place it this way, we're still looking at 16 cubic units. If I put it like this, we're still looking at a composite volume of 16 cubic units. If I want to make it 17 cubic units, well, I'll get this little guy over here and place them basically pretty much anywhere you want. And this will give us a grand total of 17 cubic units as a composite. Okay, whether I add it there or up here. No, I'm just having fun with this stuff. It makes no difference. I'm still looking at 17 cubic units. Okay, 4, 8, 12, 13, 14, 15, 16, 17 cubic units. And last but not least, let me do this. This is still 17 cubic units. Okay, and this is fun with composite volume. Lesson 10 Make it a hands-on activity. Use your paper, use your scissors, use your rulers, cut and paste. Have fun and enjoy. I'm Mr. Galvez. Catch you next time. Bye-bye.